pictures, taken during Operation Hydra 8, show for the first time in the world divers working efficiently at a depth of 530 meters. The program for developing hydrogen diving undertaken by Comex since 1983 has demonstrated beyond doubt the advantageous properties of this gas, particularly that of eliminating the high-pressure nervous syndrome, which is the chief limiting factor in helium-oxygen diving.
Témoin de toute cette évolution technologique, mais aussi un acteur. Je veux parler de M. Henri Deleuze, qui est président de Comex. Moi, j'ai envie de vous dire, on vient de voir ce résumé historique. Quels ont été les points forts, les bons souvenirs et peut-être aussi les mauvais dans cette histoire?
Dans cette histoire d'hydrogène, le point fort, c'est en 1983, lorsqu'on a fait les premières plongées humaines. On avait beaucoup travaillé sur animaux, sur singes, sur souris, et ensuite il a fallu franchir le grand pas. Et ce qui a été merveilleux, c'est que j'ai proposé à Comex un volontariat pour prendre de l'hydrogène sur une première plongée à 100 mètres, et 16 gars de la Comex, y compris l'avocat, y compris un comptable, qui sont bien entendu plongeurs du dimanche, ont accepté de prendre l'embout et de donner une opinion.
Alors, on va revenir un petit peu sur tout ce domaine, mais moi je voudrais tout de suite qu'on voit un petit peu ce qui tourne autour de votre société, ce qui tourne autour de l'offshore, ce qui tourne autour du pétrole, c'est-à-dire tout cet enjeu économique. Je vous propose un reportage de Lise Blanchet.
L'opération Hydra 8 n'est pas confidentielle. Les compagnies pétrolières, clients principaux de la Comex, ont toutes les yeux fixés sur Marseille. Le succès de la plongée est aussi important pour de nouveautés si l'on sait que les réparations sont possibles à moins 500 mètres.
Cette première plongée à 500 mètres, cette déjà une plongée à 500 000 mètres. Dans de 500 000 mètres, il y aura le développement pétrolier. Bien sûr, la tendance est d'employer au maximum de la robotique, de manière à éviter au maximum l'emploi de l'eau, mais comme dans l'espace, l'homme et le robot sont
pour assurer, je dirais, à la fois la logistique et la sécurité de ces deux autres camarades que nous allons retrouver en direct toujours, donc à 520-530 mètres de fond sur leur table de travail qui simule un certain nombre de cas de figure rencontrés dans le domaine pétrolier. Alors je sais que malheureusement nous n'avons plus beaucoup de temps dans l'émission, c'est, il faut le dire, vu d'ici bien dommage, car je crois qu'on passerait des heures à les regarder évoluer et à voir comment ils avancent dans leur travail.
The principal objectives of Hydra 6, the preparatory phase for Hydra 8, were selection of divers for the open sea dive, testing of individual diving gear, and gathering of physiological data. Psychometric measurements were made by administering daily divers tests, number similarities, ball bearing tests, etc., at 500 meters depth, and with optimum results as regards performance. The physiological research carried out during the dive involved extensive equipment and personnel, doctors, physiologists, and technicians. The diver is fitted with sensors for recording such data as core temperature, electrocardiogram, breathing gas parameters.
Aujourd'hui, au point de vue respiration. Ok, ben c'est bon.
22 underwater dives were carried out during the course of Hydra 6. The diver takes his place on the underwater ergometer to perform an exertion test with cardiorespiratory monitoring. The temperature of the gas inhaled and exhaled is measured by thermoprobes. A mass spectrometer measures the composition of the breathing gas in real time. Ventilatory resistance is checked by measuring the differential pressure between inspiration and expiration. The positive results of these tests and checks made it possible for us to go ahead with the sea dive at 520 meters. Hyperbaric tremor appeared in 3 of the divers upon arrival at 180 meters on heliox, but this completely disappeared after the switch to hydrogen mix. No problems with vision were observed at 500 meters. Between dives, the psychometric tests continued. Brain activity was measured by electrodes fixed to the diver's scalp, which produced periodic electroencephalograms both day and night. The diving program in the pool chamber continues. The diver must build a model, a puzzle, with lengths of piping. The diver is kitted up with an X-Lite helmet and bailout system, the latest gear designed and made by Comex Pro. The Boss backpack is connected to the helmet and provides sufficient gas for the diver to return to the bell in good time if his umbilical supply fails for some reason. After 96 hours at 500 and 520 meters, the 8 Hydra 6 divers are decompressed. In hydrolyox decompression, the hydrogen is gradually removed from the mixture. This is done by means of a system designed and built by Comex engineers called the dehydrogenator. The hydrogen is oxidized and removed in the form of pure water at the rate of decompression selected. During dehydrogenation, each of the divers was checked for circulating bubbles every 3 hours by means of Doppler detectors which recorded the signals on tape. No circulating bubbles were detected in any of the divers at any time during decompression. Decompression took 17 days and 20 hours, ending on December 18, 1986. A final study of narcosis on hydrogen was later carried out on 4 divers during Hydra 7 from January 5th to 20th, 1987. The divers were finally able to emerge from their chambers after confinement of 28 days. They were met by Comex President Deleuze, Dr. Fructus, Commander Couillot, and all of the members of the scientific and technical staff. The 8 divers selected to participate in Hydra 8, including 2 standbys, underwent intensive physical training for 1 month prior to the dive. Their performance was measurably improved by using the interval training method practiced nowadays in so many sports. As none of the divers had practiced swimming as a competitive sport, their pool training concentrated mainly on endurance. Meanwhile, there was feverish activity aboard the Aurelia, the dive support vessel for the Hydra 8 dive, which was docked in the port of Marseille. All of the ship's diving system had to be converted for this first offshore use of hydrogen. A maximum amount of equipment, and in particular the gas supplies, was stored on the deck. Everything is readied for the great adventure. On February 22nd, President Delos and Commander Couillot give a press conference aboard the Aurelia.
C'est une expérience de plongée sur cette table de
This diving operation is going to take place on this work platform, which will be lowered by crane to a depth of 520 meters. Offshore Marseille, the continental shelf is only 80 to 100 meters deep, so we have to carry out the operation offshore Cassis in Cassidagne Canyon, where the depth ranges from 500 to 2,500 meters. It's the only spot in the vicinity of Marseille. The 6 participating divers say farewell to the daylight and the sea breeze and enter the Aurelia to enter the chambers where they will live for 30 days. Everyone's in a good mood and they're not faking it. These are pros who've chalked up thousands of hours of saturation time, some of them in the 300 to 500 meter depth range.
Salut, au revoir.
Et Serge?
Allez, ça ira mieux dans un mois.
Toi de fait.
On va commencer dans tout est là.
Bon, bah, allez, calcule encore.
Serge. On peut te calculer, t'inquiète pas. Ciao. Non, mais c'est super la dernière fois.
The countdown is finished now, and the divers are beginning to be pressurized to 500 meters depth.
2 mètres de profondeur.
Compression will take 3 days and 22 hours and will be done on heliox down to 250 meters, on hydroliox down to 500 meters.
Plongeur.
On February 24th, in spite of a violent Mistral wind, the Aurelia leaves dockside under her own steam and heads for the Cassidagne site. She takes up her position over a 540-meter depth, a position which will be held during the entire operation in spite of the bad weather by the dynamic positioning system, comprising a whole battery of sophisticated instruments. References are furnished by 2 taut wires, a Simrad beacon on the bottom, and an Artemis beacon on shore. The area around the hyperbaric chambers is inerted and maintained at a pressure of 500 millibars by large stocks of liquid nitrogen and a pressure-reducing system. Those working in this area have to wear closed-circuit breathing apparatus. This carefully controlled nitrogen atmosphere around the chambers protects the ship's infrastructures in the event of hydrogen leakage. Pressurization of the divers to their living level of 500 meters is now over.
Je mets en route la 80.
The underwater worksite is a metal work table containing a length of pipeline with spool piece, tools, and other equipment with which the divers will carry out a complete sea line connection. The work table is launched by a crane and will be lowered to the bottom by winch. In the cabin of the ROV Sea Worker, the pilot surveys the descent on his monitoring screens. The work table is installed at 520 meters. Visibility is excellent. The Triton is standing by, ready to send out its submersible. Liaison with shore is via helicopter, weather permitting. Henri Delos and his fellow workers are constantly on hand in the dive control room, operational headquarters of Hydra 8 throughout the diving operations. The checklist completed, the first diving team is standing by in the bell. The diving supervisor is in communication with the divers via intercom and TV monitor at all times, thanks to strategically situated TV cameras both at the surface and underwater.
Bon, Raymond, tu envoies tes gars au déclampage, là.
The bell is disconnected from the chambers and begins its long descent to the bottom at 520 meters. During the dive, the hydrogen mix is distributed from a specially designed container.
On est profond. 320 mètres.
Another container houses the analysis lab, where composition of the different gas mixes used for the operation is checked by chromatograph. There's a certain degree of suspense in the control room when the bell reaches 500 meters. Patrick Esther gives a live news commentary of this historic moment for Channel 2 French TV.
Et je vous propose de voir tout de suite quand même la première image de cette tourelle fournie par un robot manipulateur télécommandé au fond de l'eau à moins 522 mètres exactement, en ce moment en direct.
The first diver is kitted up in the rather cramped space of the bell and lowered into the water by means of a small hoist. Alone under the bell, in the glare of the spotlights, the first diver waits for his buddy. The second diver has put on the helmet hanging from the ceiling of the bell and goes out. The two divers are ready to proceed to the work table. They await orders from the surface. All of the physical and physiological data, core temperature, breathing, etc., is continually gathered by computer. The two divers follow the cord connecting the bell to the work table, which is suspended from the Aurelia by wire rope. 4 guide ropes secured to the bottom prevent the table from moving horizontally. The diver's first job is to make precise measurements of the position of the 2 pieces of pipe between which the spool piece is to be installed. They use the measuring equipment provided for this purpose. The judiciously combined counter effects of helium and hydrogen afford the divers a degree of breathing comfort as well as a general physical and mental well-being never before experienced below 300 meters on heliox. The bellman, who is in communication with the divers, is ready to bring them back to the bell. After 2 hours and 25 minutes of work in the water, the two divers come back to the bell. The bellman recovers the diver umbilicals and coils them up. The diver is fastened to the hoist by his safety harness and raised into the bell to save him further exertion. Talking over their impressions, the bell rises to the surface. The bell umbilical is hauled in and coiled in its storage bin. After 45 minutes, the bell appears in the moon pool. It is mated to the transfer lock. The chamber control operators take over the divers as they return to the surface habitat. The many visitors are ferried to the Tianhe by means of the traditional basket, since the sea is still choppy. Between dives, the divers undergo an electrocardiograph check at rest and during exertion.
C'est votre fréquence habituelle. On attend une minute comme ça, voir si c'est stable.
Monsieur Madelin, French Minister of Industry, is received aboard the Aurelia to watch a diving operation.
À 5 fois la longueur du bateau. Et l'engin télécommandé dont je vous ai parlé, donc vous voyez sa cage et vous voyez à l'échelle le ROV en train de se balader le long de sa laisse horizontale avec 150 mètres de possibilité. Affirmatif.
The bell is again at 500 meters, and the divers are ready to work on the subsea work site. Like the astronaut in space, the aquanaut leaves his habitat. The equipment is similar, as is the three-dimensional behavior, but the physical environment is quite different. Here there is an absolute pressure of 53 atmospheres. The submersible Griffon is on duty at its station with the operator inside. The divers here must be conferring about some technical problem or other. The spool piece is moved by means of overhead traveling cranes. On real offshore oil work sites, the divers often position huge spool pieces weighing dozens of tons. The material used for Hydra 8 may be smaller and lighter, but is nonetheless the same material actually used for offshore oil jobs. Now the flanges are aligned. The threaded shanks and nuts are positioned. The divers' movements prove they are completely at ease. The less voluminous heated suits and the gas reheating system provide maximum thermal comfort. The nuts are tightened slightly with a wrench. They will be definitively tightened by means of a hydraulic cylinder system named Hydra Tight. The cylinders are installed on the shanks. Hydraulic feed lines are connected to each ram for the tightening operation. The tightening torque will be remote controlled by an operator on the surface. Once the flanges have been tightened, the Hydra tights and hydraulic hoses are removed. The 6 divers totaled 6 dives in the water at depths between 520 and 534 meters for bottom times of more than 4 hours, for a grand total of 26 actual man-hours of work. deepwater saturation on hydroliax mix was withstood extremely well by the divers, making industrial application of this new breathing gas a practical reality. The Belle starts its last ascent. As soon as it reaches the surface and the divers transfer into the living chambers, final decompression begins. Decompression lasted 17 days and 11 hours and went off without any problems. The technological mastery demonstrated in the manipulation of hydrogen throughout the Hydra 8 operation leads us to envisage regular use of Hydrox on offshore oil work sites. The invaluable ROV Sea Worker provided close observation of the subsea site and images for live television broadcasts. Decompression from Hydrox is carried out by gradually removing the hydrogen in the mix, that is, dehydrogenating it from 500 to 300 meters. From 300 meters on, the divers breathe heliox. They're feeling great and are of course impatient to get out into the open air after being cooped up for 30 days. In the restricted space of the chamber control room, a crowd is waiting and all of the cameras are aimed at the pressure-locked door, which finally opens on March 22, 1988 at 1700 hours. The Comex and French Navy divers who participated in this Hydra 8 operation do their best to please the photographers. For Henri Deleuze, this latest success is the result of 25 years of untiring effort and research. A new era of industrial progress has begun beyond the sea depth of 500 meters.